Section 1, we will review factoring polynomials. For a more in-depth look at factoring polynomials, I would encourage you to look at Module 6. Let's start by reviewing one term, and that is the greatest common factor. The greatest common factor is the largest quantity that is a factor of all the integers or polynomials involved. To find the GCF, follow this three-step process. Write each number or polynomial as a product of prime factors. You can do that by using a factor tree. Second, identify any common prime factors between each number or term. And third, take the product of all common prime factors. If there are no common prime factors, the GCF is 1. And remember, with variables, the smallest exponent for each variable that the variables have in common between each term will represent the number of variables you need in the greatest common factor. After we factor out the GCF, we're going to use a process called factoring by grouping. Hopefully you remember that as we factor by grouping, we are really looking for 3 GCFs. One for the first group, one for the second group, and then one for the resulting group. And so let's take this example, xy plus y plus 2x plus 2. We would create 2 separate groups. Usually we just use the first 2 terms together and the last 2 terms together. As we look at the first 2 terms, x, y, and y, we see that the GCF is y. When we look at the last 2 terms, 2x and 2, the GCF is 2. On the next line, we factor out the first GCF. We then factor out the second GCF. And as a result, we see that each term has a binomial factor in common, the x plus 1. So finally, we factor out the binomial factor, and we would be finished factoring by grouping. By-step process to factor by grouping. Step 1, we factor out the greatest common factor, if there is one other than 1. Step 2, we take the resulting trinomial, and we want a number or 2 numbers whose product is a times c, but whose sum is the coefficient of the middle term, b. We then write the middle term using the factors that we just found and factor by grouping, that process we looked at on the last slide. Here we have 8x squared minus 14x plus 5. And because we don't have a GCF other than 1, I'm just going to write no GCF. The only time the GCF is even important to us right now is if the greatest common factor is a number other than 1. So we go through the first step. There is no GCF. We then multiply what we call a and c, the coefficient of the squared term and the constant, and that will give us 40. So now we're looking for 2 numbers that will multiply to give us 40, but that will add together to give us negative 14. Remember, the only way that 2 numbers can multiply and be positive, but add and be negative, is if each of those numbers is a negative number. So we go through the factors of 40. I'm just going to write quickly: 1 and 40, 2 and 20, 4 and 10, and then we would have 5 and 8. And remember, we just said that each of these factors would have to be negative. So as we look at the sum of each factor group, negative 1 and negative 40 would give us negative 41. That's not what we want. Negative 2 and negative 20 give us negative 22. That's not what we want. Negative 4 and negative 10 give us negative 14. That's exactly what we want. So we found our factor pair. Once we do so, we replace the middle term and the original trinomial with these 2 factors. And it looks like this: 8x squared minus 4x minus 10x plus 5. Make sure those 2 terms that you put into the original have the same variable as your original term. Now we're going to factor by grouping. I group the first 2 terms, and I group the last 2 terms. In the first group, 8x squared and 4x have a 4x in common. When we factor out the 4x, we divide each original term by 4x, and that gives us 2x minus 1. In the second group, 10x and 5 share a common factor of 5, but because the leading term is negative, I'm going to factor out a negative 5. We then divide both terms in the group by negative 5. That gives us 2x minus 1. At this point, we notice that each term has a binomial factor of 2x minus 1. So we factor that binomial out. When we do so, if we divide each piece by 2x minus 1, we are left with 4x minus 5. Example: 6x squared minus 2x minus 20. Again, the first step is to find the GCF, and the GCF of this trinomial is 2. So the first step, we're going to factor out the 2. When we divide each piece by 2, we get 3x squared minus x minus 10. The resulting trinomial, and we multiply the first and last term together, that gives us negative 30. So we're looking for numbers that multiply to negative 30, but add to the middle coefficient, which is negative 1. The only way we can get a negative product is by having one positive number and one negative number. If the sum is negative, the quantity furthest from 0 had to have the negative sign. So go through and use that information while you're finding the list of factors. I'll tell you that the two factors that solve each of these would be 5 and negative 6. Now please remember, once you find the factor pair, you're not finished. You use these to continue the process. So we put these in place of the middle term, and that gives us 3x squared plus 5x minus 6x minus 10. We now have a first group and a second group. So we bring down our tag-along GCF. The first group has an x in common, so we factor out the x. The second group, negative 6x and negative 10, share a common factor of negative 2. And now we see that each term has a factor of 3x plus 5. So we bring down the first GCF, factor out 3x plus 5, and each term becomes x minus 2. Example where we will go through the same process. 30a squared minus 22a minus 28. Again, we look for a GCF first, and here the GCF will be 2. So we factor the 2, and the resulting polynomial is 15a squared minus 11a minus 14. We now multiply the first and last term together. That gives us negative 210. So we're looking for two numbers that multiply to negative 210, but that add together to negative 11. Just like in the last example, because we have a negative product, we need one positive number and one negative number. The quantity furthest from 0 should get the negative sign. That's what the sum tells us. So go through and find the factors that will multiply to give you 210. Make sure that the sum is negative 11. And you will find that 10 times negative 21 is the factor group you want. So we put those two factors into the original polynomial. We then create two groups with the 4 terms inside parentheses. So on the next line, we bring down the original GCF. In the first group, we can factor out a 5a, and that leaves us with 3a. In the second group, we can factor a negative 7, and that leaves us with 3a plus 2. So we see we have a factor of 3a plus 2 in common. So for our last step, we write the original greatest common factor, the factor of 3a plus 2, and the resulting polynomial, which will be 5a minus 7. For example, 3z squared plus 5z plus 6. We look for a GCF, we find there isn't one, so we just write 1 as the GCF or no GCF. We then multiply the first and last term together. That gives us 18. So we want two numbers that will multiply to 18, but that will add to a positive 5. And as we go through the entire list of factors for 18, we see that no factor pair will satisfy both conditions at the same time. Because that's the case, we say that the polynomial is prime.